Good afternoon, ladies and gentlemen. Good to see so many of you. Oh, live swaps here. Good to see so many of you here at Hydrogen Fuel Cells Europe at the Hannover Messe 2023. We just had a very interesting talk, and we have another interesting talk coming up. I will be talking about marine and onshore transportation of compressed hydrogen with the Sales and Marketing Director of UMOE Advanced Composites. Can I get an applause for Ola Engehagen?
Yes, thank you. Hi.
So, welcome to the stage. I think it was a short walk for you over here. The booth is right over there. I think you can see it from here. So, no extra calories were spent there. UMOE Advanced Composites. What do you guys do?
We are an OEM for pressure vessels and gas containment system, especially then for storage and transportation of hydrogen, but also industrial gases like helium, nitrogen, CNG or methane, and so on.
Okay, so pressure vessels, the big tanks. Is this for mobility, for distribution, for storage?
Yeah, it's both that, also industrial, I would say. We also now focus, because we have a lot of requests also from the maritime environment. So fuel tanks for ships, large applications, because we are really focusing into large applications due to our nature. We do tanks 6 meter long, longer, 75 centimeters in diameter, and larger. So we are not into smaller applications like cars, buses, trucks, more into the larger applications like then storage systems, distribution systems, and also fuel tanks for ships, could also be cargo trains, and so on.
Okay, you mentioned the size there as something that sets you apart or makes you maybe not the best for smaller mobility applications, but I believe it's more than that, right? You're doing something different than other manufacturers, whereas the rest goes the carbon route, carbon-based composites.
Yeah, it lies into our name. We do composites. And we could use carbon for sure. But as you would see from the fair, you would find a lot of carbon manufacturers. Our strategy has been to focus into large vessels and utilizing glass fiber. Glass fiber gives some specific improvements due to safety, but also on the cost side. So it's really contributing on a lower capex and also affordable and really good OPEX.
Okay, so basically cheaper, safer?
Yeah, but also it's a sweet spot on the larger applications. That has to be mentioned because carbon does also have their sweet spot, but maybe on their smaller application where also weight is extremely important.
Okay, so you're giving in a bit on the weight, but you get a lower capex and some extra safety back for that. Okay, interesting. Your product lineup. You already mentioned you make big tanks, 6 meter long, I think you said.
And longer, yes.
Longer even. Are these standard products? Are these products that you make to order? Are they custom?
Yeah, so currently we are doing standard tanks. So suitable for 20 feet, 30 feet, 40 feet, 45 feet. And then I would say also the containment system. The containers themselves, they are quite standardized. But what is not standardized is the challenge for the hydrogen industry. Is that there's a lot of companies out there demanding their own profile on connections and so on. So that's why we're doing customized manifolds. So high degree of customization of that one.
Yeah, hydrogen still has a long way to go in terms of standardization. I think we can all agree to that, and there have already been some talks today that definitely pointed that out. So standard tanks and the manifolds are custom. Yeah. That makes sense. Okay, so where can we find these tanks? What kind of projects? Can you give some examples of where your tanks are being used?
Yeah, into mobility, we can mention one of, I would say, the Western world's largest infrastructure project for fueling trucks that you will find in Switzerland. They have currently about 50 Hyundai fuel cell trucks on the roads. We are delivering all of the transportation modules in order to bring the hydrogen from the electrolyzer site out to the different fueling stations. So currently they have 10 folds of these containment modules. So that's one of them in mobility. I can mention similar ones as far as New Zealand.
Okay.
So you will find initiatives throughout the world. Currently, we are also building a new manufacturing plant in Asia. Will open in 24. So let's see on development also for us in that area, not only in Europe or in the western part of the world.
Definitely, yeah. And I think you also mentioned, so for mobility projects, we have the thing in Switzerland you were just talking about. You also mentioned a ship project.
Yeah.
Similar?
Yeah, I would say from the start, when we established back in 2007, we were actually in the offshore and maritime environment producing huge accumulator tanks for the drilling industry, floating drilling ships, drilling rigs. Then in 2015, we started more focus on the onshore applications with the industrial gases. But now we are emerging into a maritime environment again, because hydrogen is highly sought after also as a fuel, I would say, for more near-shore applications like bulk ship traveling towards European harbors. I would say, you could go from Norway, where we are based, with hydrogen, land it into Germany or in Netherlands, in some of the huge ports. But you also have vessels along the coastline and also inland seaways, or like in Germany, in Netherlands, you have initiatives now going on to fuel ships and barges with hydrogen. So we have gained some of this experience and some ships already, but they are not built, but to be sailing in late 24, I think.
Okay, and those are of the variety with the swappable containers then, or the...
Both swappable and also fixed installations. So swappable is kind of the huge trick, because then you have to have all the certifications for the road. So you need an ADR approved container. You need maybe an RID to be on the train. And then you also need to have the approval to go on board a ship. So you have the IMDG, and if it's going to be used as a fuel, you have to have the IGF approval as well. So
sounds like a nightmare indeed.
Yeah.
Yeah, but that is something. Every time I talk to either pressure vessel manufacturers or maybe some of the, more on the shipping side, these swappable containers are something that keep coming back. But at the same time, I'm also like, okay, we already have a problem with standardization here.
There is actually
adding to the nightmare, I think. How do you see that? Do you think that is something that will be continued and that will have a serious chance of survival?
There are initiatives ongoing for standardization. Like in Netherlands, they have the Condor project. All of it is to standardize a swappable container. And then you have also an initiative in Germany. You have initiatives in the Nordic countries. So it's to bring these together and to make a really standard configuration. That's a challenge. But by the word of having swappable, it means that you are going to an harbor, you are going to unload the empty containers, get the full one on, and then it would be really beneficial to have a standardized equipped container.
Yeah, we'll have to, I think. We'll have to. Okay, so those are some of the projects that you've been working on. Are there some future projects, something you can tell us about?
Yeah, well, we now discussed about the standardized and the sizes that we do have now. We are involved in a project called Deep Purple. That's run by FMC Technip. It's about storage on the seabed, and store hydrogen on the seabed is really a good idea. You don't have to use a lot of land for safety zones and so on. It's also quite convenient if something occurs. But it's also a challenge due to the salt water. But having composite makes it much more easier. And there we are now currently developing a huge tank. The aim is to have one tank as one 40-foot container, so 12-15 meters long and 240 meters in diameter, having a possibility to store about 1 ton of hydrogen at 350 bar in one cylinder.
Wow, that sounds like science fiction to me. So when can we expect this? That is huge.
So first pilot project is already supported. It will be into a fjord, so not very deep. That will be online in 2026. So there's still some time, but we are currently doing this development work.
Super interesting. You already mentioned the past of the company a little bit. I think you came from building composite ships. Is that correct?
Yeah, so our today's sister company, where we originate from, is also a composite company building naval ships for Norwegian Marine, for other marines and so on. Frigates is one of the ship types they have built. So they have been doing this for about 40 years. So using glass fiber, carbon fiber, and we originate from that knowledge and was then established as our own company in 2007. So then focusing really on the offshore market.
And in 2007, I would say the whole hydrogen sector was a wild west, right? It was a very different place. How would you say, what changes are you seeing? What trends are you discerning that are interesting and that in your opinion we should pay attention to?
Yeah, first of all, also in 2007, even though we were not involved in the hydrogen business then, it was emerging from the early 2000 when 11 states, I think it was, among them Germany, Japan, Norway, some others as well. I think it was about 18 to 20 countries. But okay, hydrogen did not. In Japan, they started more using it and so on. In the other countries, it was a bit more slow. And in the start, when we started, it was more the established gas companies, the large ones, Air Liquide, Linde, Nippon, that really was on the horizon to also distribute more hydrogen that they already did. What we have seen the last 5 years is really a lot of new businesses coming up, new establishments, and it could be also huge utilities, not focusing on gas before, but now focusing more on gas. It could be really some startups. It could be new companies emerging from some other, like JCB, the huge excavator and I would say heavy machinery equipment in UK. They established their own company called Rise Hydrogen. So you see a lot of new creations in the hydrogen business, and that's really exciting.
Yeah, I think you can just look around here, compare it to last year, compare it to the year before, and you can definitely see that. Are there any questions from the audience? Maybe there is a question. It was very quick. Must be a pressing question then.
The lesser the compression rate is, the more standardized containers you need, obviously, to carry the same amount of hydrogen. What is currently the maximum pressure in your standardized container? And what do you think where the development will take us in the next few years?
Yeah. Currently, we have sold a lot of 350 bar containers, but 450 is the one that will come this summer. That will be the highest so far, and then we have started with the 500 bar. And then I would say going higher, I'm not so sure that it will happen in near future, but for stationary storage, maybe some years later. So I would say it's getting quite costly. Also with our technology, with the glass fiber, it's getting, to be honest, also quite heavy. So if you want to go really, really high in pressure, like 700, 900, carbon, and again, is maybe the best choice if you're going to have a transportable solution. Stationary solution is something different, which steel is the dominant today. We are challenged very much on the stationary side because we are able to offer, as higher you go in pressure, the better capex towards steel we can offer. So we beat them a lot. Maybe not on the 200 bar, it's more equal, but going higher, we should beat steel. Yep.
Yeah, and I think we were talking about that earlier as well, right? Higher pressures, more headaches, basically. That was that was it. Okay, Ola, I'd like to thank you for your time. I think we had a wonderful talk. If anyone else still does have questions, you can continue this conversation at booth D20. It's right over there, so not a long walk. Again, thank you. Can I please get an applause?
Thank you. Thank you for listening.